construction of constructing quadrilaterals. Now we all know what do we mean by quadrilaterals, right? It's a four-sided closed curve, something like this. Now, the question which comes up is that, whenever you are given several dimensions, the quadrilateral that can be constructed is something which can be different. So suppose you are told that there's a quadrilateral A, B, C, D. And there are two sides which are 8 centimeter and there are two sides which are 6 centimeter. Now this quadrilateral can be like this. So these two are 6. This is 8. This quadrilateral can be like this. 6, 6, 8, 8. Or it can also be something like this. 6, 6, 8, 8. Now, how do you find out what is the desired area of a quadrilateral? Is something that we are going to see in this particular video. So let us say, for example, I have been told that I need to construct a quadrilateral ABCD such that side AB is equal to 6 centimeter, BC is equal to 9 centimeter, CD is 7.5 centimeter, then AD 8 centimeter, and let's say AC is equal to 11 centimeter. Now, if I were to construct a quadrilateral, it could be something like this. Let's say suppose this is A, B, C, D, and then I also know AC, right? Now I know AB is 6 centimeter, BC is 9, CD is 7.5, AC is 11, and then AD is 8. But what is the exact length of this? So maybe what I can do is that I know that particularly for I know the area this is a triangle and I know all the three sides here. So maybe what I can do here is I can just start with this particular area and let's say I construct AC, which is 11 centimeter, right? Now we know that there is a point somewhere lying this point B, which is 6 centimeter from A and 9 centimeter from B. So what do? I will put my compass here. Let's say this is my compass and this is the length. I'll take the length of my compass as 6 centimeter. You hold the compass here, take it in a ruler. Wherever is this, suppose this area is 6 centimeter, extend the length of the compass to 6 centimeter, put the pointed needle here at A point, and then draw an arc. Okay, let me just kind of remove this. So I put the needle of the compass here, I measure this 6 centimeter here, and I draw an arc here. And this arc has to be 6 centimeter. Then I know that somewhere on this arc there's a point B which is 9 centimeter from C. Why? Because BC is equal to 9 centimeter. So then I take this compass, I extend it on the ruler to 9 centimeter, and from here I draw another arc such that that arc cuts the arc AC at some point in time. Wherever these two intersect, that is going to be my point B. Then I draw a straight line from here to point A, AB. This has to be how much? This should be 6 centimeter. Why? Because we are given AB is equal to 6 centimeter. Similarly, I draw another line from B to C, and this has to be 9 centimeter. Now please note that these lines are not as straight as they have to be, but when you draw, these lines have to be perfectly straight. Okay, so these two are done. Now what else? What else? There is another point D somewhere around here, because we had drafted, so we felt that let's take D point here. So now D point is somewhere here, here. I don't know where it is, but I know that from C, this point to that point D, the difference is how much? 7 centimeter. So again, on my ruler, I take 7.5 centimeter. I put the needle here and I draw an arc of 7.5 centimeter here. But what I also know is that AD is equal to 8 centimeter. So again, what I do, I put my compass on the ruler. I measure 8 centimeter through my compass, which is this. And from here, putting the needle, I cut an arc here. Of this arc has to be and then basically, what do? I do nothing. I just join this point from here to here, and I join this point from here to here. This is my point D. The length of this particular thing has to be 7.5. This has to be 8 centimeter. So this was the case where I knew the length of all the sides of the quadrilateral and the length of the diagonal AC. So this is how I basically computed and calculated and formed my quadrilateral.